Hello everybody and welcome to the Liftoff. In this video we're going to go over everything from Starship's second orbital attempt, from launch to rapid unscheduled disassembly. It's no secret that after Integrated Flight Test 1 in April, SpaceX's Stage 0, the launch pad, experienced extreme damage. But how did it do this time? Well, SpaceX has clearly learned from their mistakes and in the last 6 months have made large upgrades, especially the water deluge system, and making sure that the rocket got off the pad faster this time, reducing stress on the pad in the meantime. As a result of these efforts, much less damage to the launch pad has been detected. This will likely mean a quicker turnaround for IFT 3, as it's much harder to get regulatory approval from agencies like the FAA if you have concrete from your launch pad flying everywhere. IFT-2 started on a high note when the booster's 33 engines accelerated the rocket faster than ever before. Anyway, let's jump to a part of the launch we can actually analyze. Alright, so something important to understand as we watch the booster shut down its engines is the G-forces involved in this part of the mission. We can tell right now that positive Gs are being experienced, mainly because both ships are accelerating, Starship's 3 vacuum engines and the booster's 3 sea level engines. Anyway, we are now at the hot staging separation, which I see as a major success. I'll tell you about that later. But what we can notice here is the booster, presumably accurate telemetry, is experiencing negative acceleration and negative Gs. Worse yet, this negative force is being experienced right at the point of relighting the Raptor engines. At this point, the booster is likely experiencing major issues in the startup process of the engines. Let's watch for a little bit as they start to falter. Okay, so what we see here is one of the engines fail to reignite. This is okay at this point and wouldn't result in a mission failure, as reigniting an engine is quite hard. We see one of Booster 9's core engines fail. Note that this engine never shut off or had to reignite. This is an indication that the booster is experiencing a widespread issue to do with fuel challenges or structural malfunctions. More about that in a sec. Anyway, the engines keep on dying one by one until just one is left, and at T plus 3 minutes and 17 seconds, Super Heavy explodes. First, sloshing. Remember that severe decrease of speed? Well, it wouldn't be hard to imagine that this negative G-force pushed the remaining fuel in the booster up before crashing it down seconds later, causing structural issues that resulted in the destruction of Super Heavy. But if we zoom in on the video, we find something quite peculiar, which makes us ask this question: where did it blow up? Leading up to the explosion, most of the damage is seen towards the bottom of the booster. We can see engines cutting out and what looks to be leaks coming from the bottom. However, zooming right onto Super Heavy in its final moments, we can see the explosion originates from the middle of the booster, with the rupture point being far away from the predicted point of mass stress. Anyway, let's take a look at the other way Super Heavy could have blown up. Let's start by looking back to those negative Gs experienced in the booster during hot staging. Well, there's a chance that in the booster's pitching movement that some engine intakes were filled with gas for a short period of time, instead of the fuel as intended. You don't need to be a rocket scientist to understand this, but the summary is the pressure of the intake changing so fast may have caused structural challenges on the booster, ending either in the oxygen and methane mixing further up the booster, or the accidental triggering of the flight termination system which exists in that region of the booster. Alright, so now that we've looked into Stage 1 and 0 of the Starship IFT-2 mission, we haven't yet looked at the Starship Stage 2, and at the time of writing this there isn't much information that concludes anything about its fate, but I'll go over a few hypotheses. Right, so both of these have to do with two things. Number one, the onboard flight termination system. But the second is something new, because if we pay close attention to both stages and play the video over a large period of time, we can see that the level of fuel is slightly uneven, with more liquid oxygen by what seems to be a ratio of several percent. This caused no issue in the booster that we can see, but maybe it didn't have enough time to. Looking at Starship, this liquid oxygen surplus remains until suddenly it goes down. This observation is supported by periodic flashes that were coming from the Starship as it approached orbital velocity, but we're really not sure if this is correlated. Anyway, this brings us to two options. First, the onboard flight termination system detects this loss of fuel, recognized that the ship would not make it to orbit, and activated the charges. Or the loss of fuel is also inside the rocket, which is obviously not very good for a spacecraft. Regardless, the result was the same and we saw Starship explode. Now, finally, we get to answer the question in the thumbnail. Was this test a do or die for SpaceX, and will the fact that both stages blew up affect the company as a whole? Well, from first looks, no. SpaceX is already jumping on the next test and hinting at a potential IFT-3 before Christmas, and has many more launch vehicles in production. SpaceX is an engine that will take more than one failure to falter, and so for now, it looks like Starship and SpaceX will be just fine.